Hi class, this is section 2.4, which is applications. All right, so for this first example, they give us an isosceles triangle, and they're showing us that the two hypotenuses are on each side is 24 in length. So they want us to find the altitude, which is x, and this other leg, which is y. So we can start off by finding the altitude by using the sine of 52 degrees, which is opposite over hypotenuse. So that would be our first equation. Sine of 52 degrees is opposite over hypotenuse. And now if we multiply both sides by 24, that will isolate x. X will equal 24 times the sine of 52 degrees, which is I'm getting 18.9. If we round to one decimal place, 18.9, that would be our x. And then as for our y, we can use adjacent over hypotenuse, so that would be cosine. So cosine of 52 degrees is adjacent over hypotenuse, and then the same technique would apply here. Multiply both sides by 24. That will isolate the y. Y will equal to 24 times cosine of 52, which is 18.9. All right, so we got the same for the two sides. All right, so that's how we would do this problem. All right, let's move on to the next example. This is a definition. The definition of the angle of elevation would be this acute angle, and the angle of depression will be when the angle goes down as opposed to up. All right. So here we have an example of a flagpole that is 75 feet tall, and the shadow is 43 feet long, and so they want us to find the angle of elevation. So we'll call it theta, and we can use our tangent function because tangent is opposite adjacent, so that would be the tangent of theta, which we do not know, is 75 over 43. In order to find the angle, we can use an inverse function here. So theta is equal to the inverse, tangent inverse of 75 over 43. Using our calculator, make sure you're in degree mode. That'll give us inverse tan of 75 divided by 43 is 60.2 if you round to two decimal places. All right, so that would be your angle of elevation. For the next example, now they're giving us a definition of the bearing of a line. It's the acute angle formed by the north-south line and the line L, and it's used in navigation and surveying. All right, so let's take a look at an example. So San Luis Obispo is 12 miles due north of Grover Beach. So here's Grover Beach. SLO is right above, 12 miles north of it. What is the bearing of San Luis Obispo from Arroyo Grande? So we want to find the bearing of San Luis Obispo from Arroyo Grande. So here's Arroyo Grande, here's San Luis Obispo. So the bearing would be this angle, theta. So it's going to be of the form north, some angle, west, because the angle is going this way. So it's going to be north, a degree measurement, followed by west. All right, so let's see if we can find that. Because these lines are parallel, and this is a transversal. In geometry, we learned that these are alternate interior angles, and alternate interior angles are congruent. So therefore, these are both the same. They're both theta. And this is the angle that we're looking for, the bearing. So that's equivalent to finding this angle. So we can use a tangent function, opposite over adjacent. So the tangent of theta is opposite over adjacent. So inverse tangent would be used in this case to find the bearing. And if you use that, inverse tangent, 4.6 divided by 12 is 20.97, which is going to round up to 21. I'm going to round that up to 21 degrees. All right, so we would say that the bearing is north 21 degrees west. As our final answer. And there it is right there. All right. The next example deals with the helicopter. They give us a scenario where it's hovering over the desert and then it's forced to land. There's a pair of radar stations located 25 miles apart along a straight road. So here's the straight road. It's 25 miles long between these two bases. The bearing of the helicopter from one station is north 13 degrees east. That would be this one. And the other is south 19 degrees east, which is this one on this side. And then after doing some calculations, the pilot must walk due west for 3.5 miles to reach the road. Is this correct? So in other words, from the point where they land to the road is this length. And we want to know if that's equal to 3.5. That is the question. So let's find out if that is 3.5. The measurement of y is what we're looking for here. So it looks like we can set up two equations. One equation would be tangent of 13 is opposite over adjacent. So let's write that out. So tangent of 13 degrees is opposite over adjacent. And then same thing goes for this angle. The tangent of 19 degrees is equal to opposite over adjacent. Now you have two equations with two variables, so we should be able to solve for these two variables. Let's see here. We can substitute. Why don't we solve both equations for y, and then we can set those two equations equal to each other. So you can multiply both sides of the equation by x here, and over here, 25 minus x. All right, so for the top equation, we have y equals x tangent 13 degrees. For the bottom equation, we're going to have 25 minus, well, all right, y equals first. Y equals 25 minus x tangent of 19 degrees. So now we can set these two equations equal to each other because they're both equal to y. And at the same time, I'm going to distribute here. So we should get x tangent of 13 degrees is equal to 25 tangent of 19 degrees minus x tangent of 19 degrees. And since you have two x's here, we want to get both x's on the same side so we can factor out the x. So add x tangent to both sides. Cancel, cancel. And as you can see, we'll be able to factor out the x. So that's what I'm going to do here. I'm going to factor out the x, which is a common factor. So now we have tangent of 13 degrees plus tangent of 19 degrees is equal to 25 tangent of 19 degrees. And now, if I divide both sides of the equation by the parentheses, I will get x isolated. So let's do that on the next page. So it should be x is going to equal, 25 tangent of 19 degrees divided by the parentheses, which was, or is, tangent of 13 plus tangent of 19 degrees. Let me double check, and that is correct. So now if we work this out on our calculators, we should get 25 tangent 19 degrees divided by parentheses, tangent of 13 plus tangent of 19, close parentheses. I'm getting 14.96, so I'm going to round that to 15 because they want two significant digits, so that would be 15. All right, and that would be, I believe, in feet is what we're talking about here. Miles. So miles. And remember, what we're really looking for is y, not x. This is the length that we really are concerned about. And so to find that, we can plug it into this equation. We plug in what we got, which was 15 for x, into this equation, and that'll allow us to figure out what y is. So y is equal to 15 times tangent of 13 let's see what we get here. 15 tangent of 13 is 13.5. I'm sorry, 3.5. If you round to two significant digits, which is exactly what they want us to do, and that is miles, which means that the information given to the pilot is correct. All right, that does it for the lecture notes. Now let's move on to the homework. Here's the homework. I will leave you guys to these two problems here, these basically definitions or fill in the blank problems. This next problem is asking us to figure out which of these choices gives us the angle of elevation from the eye of the surveyor to the top of the opposite building. So that would look, here's the surveyor, that's the horizontal line, and this would be the angle of elevation that we're looking for, and it should be 40. So this is not correct because this is not correct. So it looks like it would have to be this one. Angle of elevation is 40. So this would be your correct choice. The bearing of B from A, so B from A is given by north 60 degrees east. So that means that the 60 degrees should be here, not here, because that's the way you read bearings. You read them from north or from south to west or to east. In this case, we're reading from the north, and it's going eastbound. So the angle 60 should be in between this horizontal line, this vertical line, and this B line. So that would not be the correct answer, not be the correct answer. It's got to be this one. For this next one, they're asking us to find the diagonal. No, the diagonal of the rectangle is 340. So we're given the diagonal. Let's draw the picture down here. That's not a rectangle. There we go. Here's your diagonal. And that is 340. Right triangle here. And the longer side is 275. Find the shorter side of the rectangle. So we can call that x. So we can apply the Pythagorean theorem. X squared plus 275 squared must equal to 340 squared. And now we can solve. I'm going to go ahead and take the square root of both sides to get our final answer. So whatever this is, that should be our answer. So let's figure that out. That would be 340 squared minus 275 squared. The square root is getting 199.9. Do they want us to round to the nearest whole number? So that would be 200 actually. So once we have that side, now we should be able to find the angles of the diagonal made with the side. Okay, so let's just uncover that. That is 200 as we have just figured out. The angles of the diagonals made with the sides would be this angle right here. And actually these two angles. So we need to figure out what these two angles are, and we separate them with commas. So let's see, we can use, I'll call this theta. So I'm going to use tangent. Tangent of theta is equal to opposite over hypotenuse. And now I would use the inverse function to find the angle measurement. And that should do it. So theta will be inverse tan of 275 divided by 200, which is 53.97. Do they want us to round to the nearest whole number? Yeah, the nearest degree. So that would be 54 degrees. And since these two angles are complementary, this would just be 90 minus 54. So the other angle would be 90 minus 54 degrees, which is 36. So the two angles are 54 and 36 in no specific order. And so there they are. All right, the next example is the flagpole example. So they tell you the height of the flagpole, and then the length of the shadow. So we can do this on a separate sheet. So the flagpole is 76 feet tall. The shadow is 51 feet long. This is your right triangle. And they want the angle of elevation, I believe. Yes, the angle of elevation is given by that angle. So once again, we will use tangent again. Opposite over adjacent. Inverse tangent will be 76 divided by 51, the ratio. Inverse tangent of that, which is 76 divided by 51. Getting 56 degrees. And I believe they want us to round to the nearest tenth. So that would be 56.1 degrees. Yes. And as for the last problem, actually there's two more problems. So let's look at this one. So an ecologist would like us to find the height of this tree, the redwood tree. And they give us some information. The angle, point A, from point A, he finds that the angle of elevation to the top of the tree is 12.2. So this angle here, I'm going to separate this triangle out for us. There's a tree. So this angle is 12.2 degrees. He then walks 24.8 feet to the right. So that would be this right here. Okay, that's 24.8. Right. And then he finds the angle between A and B. So this other angle that goes over here, that angle would be 87.2 degrees, this angle here. What is the height h of the tree? So ultimately, we're looking for the height of the tree. We're given this side and this angle, so we should be able to find this using trigonometry, because this is also a right angle down below. So I'm going to go ahead and call this, all right, so we're going to use, I'll call this x. So we're looking for this side first to begin with, x, and we can use opposite adjacent. So tangent of 87.2 degrees would be opposite over adjacent. And now we can solve for x by multiplying both sides by 24.8. So x is equal to 24.8 times tangent 87.2, which I'm getting 507.07. So now we have x and now we can use this this angle here and do opposite over adjacent again with this right triangle now. So now we have tangent of 12.2 degrees is equal to opposite over adjacent. And once again, multiply by the denominator. And that's how we can get h by itself. So h will equal to 507.07 times tangent of 12.2, which is 109.6. They want us to round to one decimal place, so that would be 109.6 feet. There it is. All right, for the last example, there's a helicopter that's forced to land at sea, and there's a station at point C, and they give us a nice diagram. They tell us that this angle is 59 degrees here. That would be from C to 59.0 degrees northeast. Okay, so that would be this angle right here. So let's draw that triangle out so it's a little bit easier to see. So this is point A, this is point B, this is point C. This angle is given to us as 59 degrees. All right, we're given this height. A is 417. All right, and then this angle DCB DCB, this angle right here, is given to us as 12.9. So I'm going to draw this triangle off to the side. So here's 417, here's B, and this angle here, which I'm not going to draw on this other diagram, this angle right here is this angle right here, and that angle is 12.9 degrees. So given that, we should be able to find this, which would become this hypotenuse over here. So we'll call it X, and then we can use opposite over adjacent. So tangent of 12.9 is 417 over X. All right, now we can solve for X. So if you solve for X, you're going to get X is going to equal to 417 over tangent of 12.9 degrees. And that is getting 1820.7. So that would become this distance here. All right, and now that we have this length and this angle, we should be able to figure out the distance from the rescue boat to the fallen helicopter. So this distance here is what we're actually looking for right there. So now that is what I will call Y. So we can use opposite hypotenuse. All right, so that's going to be our next equation. Sine of 59 degrees is opposite over hypotenuse. And if you multiply both sides by the denominator, that will do it. So y will equal to that number times sine of 59 degrees, which I'm getting 1560 point. They want us to round to the nearest 10 feet. Nearest 10 feet would be 1560 would do it. Feet. So let's see here. Whoops. Yeah, because that's the 10th place. Basically, they want us to round to the 10th place. So this is the place value that we're supposed to round to. And that will do it for today, for this section.